Guys, in this video today we will discuss about the solving linear recurrence relation of second order by characteristics root method. So here now I'm going to discuss with you that how can we solve a system of linear recurrence relation of second order by characteristics root method. So let's see. And suppose if we consider here a second order recurrence relation like an plus c1 an minus 1 plus c2 an minus 2 is equal to 0. This is a second order linear homogeneous equation. Linear homogeneous recurrence relation. So now the question is that how can we solve it? Suppose, and here we have to find the characteristics equation. The characteristics equation of this system of linear equation, the characteristics equation is x square plus c1x plus c2 is equal to 0. And now we have to remind here always one thing, that the roots of this characteristics equation are always real. Roots of this of the equation, if we denote it 2, that we can say the root of the equation 2 are always real. And we know that if we consider and see, the number 2 is a quadratic equation. Number 2 is a quadratic equation, and since this is a quadratic equation, so its roots are two types. Number one is real and distinct, and another one is real and equal. And now if the roots of the equation is real, and now I'm just telling you one thing, that if the roots are real and distinct, then the solution, the general solution we will write. And suppose if this is a real and distinct, suppose the roots are like x1 and x2. These are the roots. Then the solution an is equal to, we can write a into x1 whole to the power n plus b into x2 to the power n. And if the roots are real and equal, then suppose the roots, and that is suppose x, then the solution is on the form an is equal to a plus bn into x to the power n, and both the cases, and for both the cases, the capital A and capital B are arbitrary constants. Are arbitrary constants. So I hope after this you have a clear idea. So now I'm just going to discuss with you two problems that were the roots of the characteristics equation is real and distinct, and the second one were real and equal. So now let's see. So now here I'm just going to solve, or I'm just going to show you two problems here. That first one, here the question is that we have to solve the system homogeneous equation like an minus 3an minus 1 plus 4 an minus 2 is equal to 0. And n minus 2, a0 is equal to 0 and a1 is equal to 5. So now we have to solve this question. So let's see then how can we solve it. So here this is the equation an minus 3an minus 1 plus 4an minus 2 is equal to 0. So the characteristics equation, be like that x square minus 3x plus 4 is equal to 0. And now if we solve it, we can get x square minus 4x plus x square minus 3x. Oh, sorry, this one is, there is a wrong. This one is minus. Okay, this is minus. That is a reconciliation is an minus 3 n minus 1 minus 4 n minus 2. So from here we will get x plus x minus 4 is equal to 0, or we will get from here x minus 4 into x plus 1. sorry for the invariance. So from here, what we get? X is equal to -1 and 4. So roots are real and distinct. So now the solution we can write, that is n is equal to a into -1 whole to the power n plus b into 4 to the power n. So now see here there is two values are given, that is a0 is equal to 0 and a1 is equal to 5. So by using these two results, we'll find the value of a and b. So now if we give in number 1, so and now if we put n is equal to 0 in 1, what we get? That is a0 is equal to a into -1 to the power 0 plus b into 4 to the power 0. So now from here we can easily write that a plus 4b is equal to 0, and also if we put n is equal to 1 here, so we get that a1 is equal to a into -1 plus b into 4, and the value of a1 is given 5. So from here we can write 4b minus a is equal to 5, and from here we know that a is equal to minus 4b, uh, that is 4b minus a, and the value of a1 is given 5. So now from here we can easily say that a minus a into -1 or 4b minus a is equal to 5. So now from here, that is a is equal to now minus 4b, and 4 into 0, sorry, this is a plus b is equal to 0. This is a plus b, 4 to the power 0 means 1, so a plus b is equal to 0. So a is equal to minus b. So from here, if we put that a is equal to minus b, so we will get from here, and if we use this result here, we can write that 5b is equal to 5 or b is equal to 1. And if b is equal to 1, so we can say a is equal to minus 1. So I think the calculation is clear to you. And next, we can write the solution is of the form, from here we can write the solution is of the form that an is equal to -1 into -1 whole to the power n plus 1 into 4 to the power n, or more simply, we can write -1 whole to the power n plus 1 plus 4 to the power n. So I hope this one is clear to you. And now, in the next, I will show you another one problem where the roots are real and equal. So write the next question. That is, suppose if we consider the equation like Tn, suppose there's in the question that Tn is equal to Tn plus 90n minus 2 is equal to 60n minus 1. So from here, we have to solve, and here it is also given that the condition T0 is equal to 1 and T1 is equal to 6. So how can we solve it? This is the equation given. So now, if we want to solve it, let's check that how can we solve it. This is very easy. That is a characteristics equation. Is x square minus 6x plus 9 is equal to 0, or you can also write first the equation Tn plus 90n minus 2 is equal to 60n minus 1, or you can write Tn minus 16 minus 1 plus 90 and minus 2 is equal to 0, and if you follow it, then the characteristics equation is like this. Or from here we can write x minus 3 whole square is equal to 0, so we get x is equal to 3 and 3. So now from here we can say that how can we solve it? That is, so now the solution is of the form an is equal to a plus bn into 3 to the power n. And see here, these roots are real and equal, so we can write the solution is this form, and also given, sorry, this one is Tn, that is Tn is equal to a plus bn whole to the 3, and given that the T0 is equal to 1, and if we put If we give it number 1, so we can write that t0 is equal to 1. That means from here, we can write a is equal to a into n is equal to t0 is equal to 1 and t1 is equal to 6. That is t0 is equal to 1. So from here, what we get, if we put n is equal to 0, that is a into 3 to the power 0 is equal to 1. So from here, we get that a is equal to 1. And if we put n is equal to 1, that is we get t1 is equal to 6. So 6 is equal to a plus b into 3. And so from here, we get a plus b is equal to 2 or b is equal to 1. So this is very simple. So the general result is tn is equal to 1 plus n whole to the power 3 to the power n. And sometimes it is also given from here that find t4, t5 and so on. So after finding the general formula, then if there is given that find t4 and t5, so just put n is equal to 4, so and then you will get the desired result. So I hope you will understand the answer, that how can I find the 5, that is 405, and if you simplify, that is 305 means 3 to 43 into 6, that means you will get 1458. So I hope you understand that how to solve the system of linear equation by using characteristic suit method. So thank you for watching the video. Thank you.